The Köppen classification system. So the Köppen classification system is the classification system for climates that is based on average monthly values of temperature and precipitation. And this was developed by German climatologist Vladimir Köppen. It was originally based on distinct vegetation found in different climates because, as we know, plants can't move around and they are dependent on certain amounts of light and moisture and temperature. This was revised to include temperature and precipitation to make it less subjective. So vegetation is still part of this. Like you can look and see if the vegetation is all cactuses, for example, or cacti. Then it's a desert probably. If it's a bunch of deciduous trees, it's probably a temperate climate, etc. Over here, we have some examples. You have Reno, Nevada, and you kind of see this precipitation down here on the bottom. It's pretty low all year. And our temperature is kind of low in January, increases up through June and July and August, and then decreases back to December. So this is January through December across the bottom here. So it's low in the winter, it's high in the summer, it's kind of cyclical. So here we have New Guinea, which is a tropical rainforest area near the equator. And you kind of see monthly precipitation varies from about 28 up to about 32-ish centimeters per month. Drops a little bit in the summer and then comes back up in the winter. So during the winter months, you have more precipitation. And then temperature year-round is right around 26, 27 degrees Celsius. So you got to be careful with these. We got precipitation on this axis. You got temperature on this axis. So worldwide climates. So the Köppen classification system contains 5 main climate types. So we have tropical climates, we have dry climates, we have mild climates, we have continental climates, and we have polar climates. We're going to talk about all of those individually. Now, most variations tend to occur in the mid-latitudes being between about, say, 30 degrees and 60 degrees north and south of the equator. Now we're going to kind of look at all of these in a little more detail here. And we have sort of our tropical climates, where we have 2 different types. You have tropical wet and dry. Well, tropical climates, especially the tropical wet climates, tend to occur sort of near the equator. So we have right here, and then all through here, we have these tropical wet climates. Then basically north and south of that, we have our tropical dry climates. So that's sort of north and south of that. Then we have our mild climates. So we have like the Mediterranean climate, sort of around the Mediterranean Sea here. We have humid subtropical climates like most of the southeastern part of the U.S. And we also have parts of Asia here in China. Marine west coast climates, kind of a large part of Europe it looks like, and then also all along the west coast of, say, the U.S. and Canada. We have semi-arid climates, basically a huge chunk of Africa here, and the Middle East with semi-arid climates or arid climates. We also have large parts of Australia. If you notice, these semi-arid climates in this sort of darker tan color tend to border between arid climates and more humid climates. You have continental climates. Again, you have warm summer, cool summer, subarctic. But the big thing to kind of notice here really is as you move from the equator, they tend to get colder, and you tend to have different bands where they are alternating sort of wet and dry type climates. So tropical climates are characterized by year-round high temperatures. If there's high rainfall, up to 600 centimeters per year, that's considered a tropical wet climate. Rainforests are common in these climates, and these are dominated by our maritime tropical air masses. So again, maritime being damp, a lot of moisture, and then tropical being hot. If there's a distinct rainy and dry season, it's classified as a tropical wet and dry climate, sort of like our graph over here for Normanton, Australia. We definitely have wet season in the winter, so December, January, February. We have this dry season in like July, August, September. So this includes African savannas, these tropical grasslands, and also some areas in Australia. Now, dry climates. So dry climates cover approximately 30% of Earth's land area. Now, this is the largest climatic zone, are these dry climates. Most of the world's deserts, including the Sahara, the Gobi, and the Australian desert, these are all dry climates. Continental tropical air masses dominate, so these are hot and dry. So the tropical means hot, continental means they're dry. Low precipitation and scarce vegetation in these dry climates. So evaporation rates exceed precipitation rates in these areas. There are two subtypes. So you have arid, which are deserts. You have semi-arid, which are semi-deserts. The semi-deserts are usually more humid, and they sort of act as a boundary between deserts. So if I have a desert area here, and I have a more humid area over here, well, I would have this sort of semi-arid region in between the two. Then we have mild climates. So humid subtropical climates like that in the southeastern United States, so like Florida and Georgia. These have warm, muggy summers and cool, dry winters. These are influenced by subtropical high pressure systems that are found over the ocean. So these actually are maritime air masses that move in and bring a lot of moisture with them. Maritime west coast, like that of Washington and Oregon. So you have this constant airflow off the ocean, which creates mild winters and cool summers with abundant precipitation. Again, you're talking about maritime air masses that are bringing a lot of moisture from the oceans that ends up falling as precipitation. So you have a lot of precipitation. You actually end up with temperate rainforests in these areas, where you actually have so much rain that is considered a rainforest, but it's a temperate rainforest. Then we have Mediterranean, like the area around the Mediterranean Sea. So this is also in parts of California and South America, where we have these warm, dry summers and these cool, rainy winters. Then we have continental climates. There are three subtypes of continental climates. So we have warm summer climates, which is kind of where we are. We have cool summer climates, and then we have these subarctic climates, which are kind of between these continental climates and our Arctic polar climates. Here we do have polar air masses and tropical air masses meet, and they form fronts. So you may have a polar air mass here, and then maybe a tropical air mass here, and then they kind of meet in the middle here. So this is kind of what's happening in these continental climates. You have these polar air masses and these tropical air masses kind of come together. So this results in rapid and sometimes violent changes in the weather. And we also end up with extreme temperature changes from summer, so tropical air masses dominating in the summer, to the winter, where we have polar air masses dominating. So it gets really warm in the summer because of the tropical air, and then in the winter you have polar air masses come in, and you have colder weather in the winter. Summers here are generally wetter than the winters. Then we have our polar climates. So we have the tundra, where we have monthly mean temperatures that are usually below 10 degrees Celsius. There are no trees. There's low precipitation in these areas, so there's not a whole lot of precipitation. There's no trees. There is some vegetation. A lot of it's low shrubby and grassy type vegetation. You have the ice cap polar climate, where the average monthly temperature never gets above 0 degrees Celsius. So there's no month of the year where the monthly average is above 0. There's no vegetation, and the land is permanently covered by ice and snow. And then we also have these highland climates. These are found near the equator. They're a lot like the tundra or the polar ice cap type climates, but these are closer to the equator, and the solar radiation is offset by elevation. So these are high enough elevations that even though there's solar radiation there, the elevation causes it to be a lot colder. So we end up with glaciers and things like that near the equator.